Hello, welcome to global-etraining.com. In this video, we will look at DHCP. DHCP stands for Dynamic Host Configuration Protocol. DHCP stands for Dynamic Host Configuration Protocol, and here are the objectives for this video. We'll understand what DHCP is, and we'll try to understand what the benefits are. So before we start diving into the DHCP and look at how it works, let us look at a small network and understand how configurations are done and maintained, and then we can appreciate what DHCP brings onto the table in terms of network administration. So here we have two computers, PC1 and PC2, or green and yellow. And in order for these computers to talk to each other, meaning we need to network these two computers, what do? We need cables, network cables, and a switch to connect them. Of course, there are certain assumptions here. The assumptions are that we have Windows installed on both the computers, and the other assumption is that we have TCP/IP installed. I mean, TCP/IP gets installed by default with the operating system, and you don't have to do much with it. So you get it with the operating system. So what do we do in order for these computers to talk to each other? We have operating system, we have the switch, we have the cables that are connected, the operating system is installed, and what are the next steps for these computers to talk to each other? Now these are the steps. So we need to assign an IP to the first computer, and then we assign an IP for the second computer. And as a part of OS installation, you assign a name to the computer, which is referred as host name. So let's assume we call this computer as green. So that's the name of the computer, and we call this computer as yellow. So if we have two computers, green and yellow, they have these IP address 10.0.0.2, 10.0.0.3. Now once we configure all these IP addresses on the system, now how do they actually talk to each other? Because green says, hey, I want to transfer a file to yellow. So how does the green computer know the IP address of yellow? Or the way around, how does the yellow know the IP address of the green computer? There are a couple of things in order to address this. Number one, either somebody else have to tell the information, or both the computers need to use some sort of mechanism to address the issue, and we'll look at what that is here in a minute. So just to recap this network, so we have two computers and a switch, and we assign two IP addresses. Everything is manual. You have to go and assign. And then you of course assign the host name as a part of the installation process. Now in order for these computers to communicate with each other, both the computers have to know each other's IP address. So that would be the situation. Just for, we have a network of two computers. Now let's see what happens when you have more computers. Now same assumption, just that we have more computers. OS is installed, TCP/IP is installed. You need to configure IP address on what? You need on all 9 machines. If you have 20, you have to do manually. That means you have to go to each machine, configure it. Now, anytime a human is involved, there's a chance of error happening. So there's a chance of human error. Now, another thing is every computer, let's refer with numbers, 6, this is 9. If 1 wants to talk to 9, then that means 1 needs to know the IP address of 9. If 9 wants to talk to 6, then 9 needs to know the IP address of 6. Now, in order to make that happen, then we will use a file called host. It's located in Windows machines. This is where it is located. C Windows System 32 drivers at C, or etc. That's a location where the file is, and the actual file name is host, and the entries look like this. It has an IP address space. There's a space here, and then there's a name. This is similar to a phone book. That means every machine has this file, and that file needs to have these entries for all 9 computers. This is similar to, let's say I have my phone book and I have all my friends' numbers. Of course, I'll not have my number in my own phone book, but there's nothing wrong in having it. Now somebody else will, let's say you have my phone number. That means in your phone book, you have all your friends' phone numbers and my phone number as well. That means everyone has to have it. What happens? I change my phone number. That means all my friends have to update their phone book. Same thing here. If we use this file for the name resolution, meaning when you say, last time on the prior slide we said green computer, yellow computer. So when green is trying to communicate with this yellow, that means number 1, on this computer, yellow, which is a host name, needs to be resolved to IP address of yellow. And how you resolve, that's a different story, but you have to resolve. That means the name has to resolve to IP address before it can start communicating. Now, if you have this host file, then you have all the IP address keyed on your computer within your host file, then your computer will be able to communicate. That means you need, similar to phone book entries. It's a manual, laborious work. And 9 computers, it's a very small. If you take corporates, you'll have thousands and thousands of computers. Then it would be a nightmare for a systems administrator to go and configure each machine manually, and there's a chance of error pretty much on every machine, right? So that's the problem that DHCP will address. It's a dynamic in nature. And let's see how this works. Okay, same thing, same network, 9 computers, and let's see how this can be addressed and how does the DHCP actually address this issue. Assign IP address automatically. That means we bring in this blue machine here. Of course, this is nothing but DHCP server. Referred as DHCP server. This machine, so when these computers come online, they will talk to the DHCP server. The DHCP server automatically assigns IP address, automatically assigns default gateway, also subnet mask, and there are other things that it automatically assigns that are required for computers to go, or work properly on the network. Now, when everything is done automatically, then what's the impact? All you do, a lot of work is just gone. All the laborious work is gone. And actually, the rest is taken care. All you need is, one system, which is nothing but DHCP server. You configure it and configure these as DHCP clients. Once you do that, these clients will automatically get the IP address from the DHCP server, and the rest is taken care of. Okay. Now let's look at the actual process. What really happens when somebody or when a computer wants to get an IP address? Okay, this is the process. You have DHCP client, you have DHCP server on the same network. when this computer is started, what it does is it sends a request out. It'll try to discover the DHCP server. And then what happens is the DHCP server on the network says, hey, you know what? You can, use an IP address. I can offer you one. And it'll send an offer. And the client will accept the offer and says, hey, you know what? I'm good. I'll use this particular IP address. And it's called DHCP request. And then once the DHCP server receives the request, it says, okay, I'm good. It'll say, okay, I'm going to mark it that specific IP address for you, and I'll say, okay, you can go ahead and use it, and it sends acknowledgement. And this is the actual process and terminology that is used, and the easiest way to remember is to remember by the word DORA. DORA, the cartoon character for the kids. It's the DORA character, so it's easy to remember. D stands for discovery, O stands for offer, R stands for request, and A stands for acknowledgement. And don't ask me why these were named this way. I still get confused. I try to remember this word DORA. If I were, I would do something like this. You have client, you have server. Thing is, number one, hey, can I get IP? And someone says, hey, here is the IP. And number three, you can say thanks as an acknowledgement. You're done. But, technically, if you look from a different perspective, this is how it works. But these are the actual, communication that happens. It's a discovery sent out, and one of the servers or any server that receives that discovery message will send an offer. There could be multiple offers actually. There could be more than one DHCP server on the network, and multiple offers might be sent, and client might receive them. Client will just pick one and send it out, and then that particular server marks it. The way this happens, let's take add some IP addresses here. A request is sent out, an offer is sent, and the offer, it says, okay, you can get an IP address of 0.0.3, and this says, okay, I'll take that offer. That's what it sends, and this sends an acknowledgement. So what this machine DHCP does is it takes this 10.0.0.3 and it'll mark it as used. What it does is, let's say this computer name is Gray. That's the name. Let's say the MAC address for this network card on this computer is, I'll just say MAC1 to keep it simple. So what this server does is it takes the IP address because it had assigned it to this machine. It puts, okay, I have assigned it to MAC1 and its host name is Gray. So next time another request comes in, the DHCP server will never assign this to somebody else because it's already consumed by this machine. So that's a process. If someone asks you, that is how you explain. Okay. Now let's go ahead and look at some terms around DHCP. Okay. Here I have the first two are static IP and dynamic IP. Static IP is where you manually assign your IP address to your computer. And dynamic IP address means it's assigned by what? DHCP server. That's why it's dynamic. What is IP conflict? IP conflict is, let's say you have two systems within the same network and they have the same IP address, let's say two, and both machines have same IP address. When this situation occurs on a network, it could be manual. Automatic will never be the case, because if it's one DHCP server assigning or sending offers out, you'll not really run into this situation. But if you manually do the mistake, then you will run into this conflict situation, and you will see literally IP conflict messages on both the systems. You will see that pop up on the screen on Windows machine. The next term is DHCP lease. What DHCP lease is, you know what, let me go back to the prior slide. Okay, here when DHCP sends an offer out, it will tell, hey, you know, you can take this IP and this is good for 5 days. That's the lease. That means this machine can use that IP address for 5 days. And then what happens after 5 days? This system, it will not wait for 5 days. It will wait for half the time. Meaning after 2.5 days, what it does is it tells, hey, you know what, can you extend my offer? Then it'll extend the offer. But then what is the real need for the lease? What happens is, let's say you got an IP address on day 1. On day 3, your computer was shut down and never came up. Let's say it came up on day 10, but the lease was only for 5 days. So DHCP server, after 5 days, it'll check, hey, you know what, the system doesn't seem to be online. It will remove this entry and make this address available so somebody else can use it. So on day 10, when this system comes online, if .3 is available, it will most likely get that IP. If not, if in the next available IP address is 21, then that's what this system will receive. So that's what is the lease. Okay, so that's DHCP lease. And some of the commands, you can use it in the DOS prompt on Windows machine. If you do ipconfig, it'll display your IP address information for all the network cards. If you do ipconfig/all, it will give you more information, meaning you will get MAC address and other details when you do /all. And ipconfig release is when you force your network card or your computer to release the IP address. The release, renew only works if it is what? DHCP Client. What you're really telling is, that you are actually a DHCP client, got an IP address from a DHCP server, and you're saying, I'm releasing it. I don't want this IP address anymore. That's what you're saying it. Now, when you say renew, what it does is it goes and renews your IP, just like renewing your library card or driver's license. It expires. Right before it expires, you go and renew your license. It's the same way with the IP addresses. Well, that's about DHCP in a nutshell. I believe it took about 17-18 minutes. Just a quick recap on DHCP. DHCP service is used to dynamically assign a network configuration to systems. If not, if this need to be done manually, it's a laborious process, takes a lot of time, very difficult to manage. There's a chance of human error all over the place, and there'll be network nightmare when you have thousands and thousands of computers. So that's where DHCP fits in and solves the problem. Well, thanks for watching this DHCP video. Talk to you later.